All right, hello and welcome to Carnegie Mellon University's Campus Engagement Day. My name is Lindsay Luciano and I'm a career consultant in the Career and Professional Development Center. Today's session is going to feature speakers from programs at the university that prepare students for careers in mechanical and biomedical engineering. Each speaker will present a little about their programs and then we'll turn it over to the employers for Q&A. For the presentation portion, please keep your microphones muted and save your questions for the Q&A. Thank you. I would like to introduce today's speakers. We have John Mellon from Mechanical Engineering, Keith Cook from Biomedical Engineering, and Peter Boatwright from the Integrated Innovation Institute. John, please go ahead and start us off.
Okay, let me just share my screen. Okay, well, thank you for joining us today and for your participation in this program. I'm John Mellon. I'm the head of graduate education for the Mechanical Engineering Department. I haven't done one of these presentations before, but I thought it would make sense to describe our programs from undergraduate all the way to PhD degrees. As an overview, our department has 41 professors, 76 staff members, including postdocs, 466 grad students, which is sort of broken up as 216 PhDs and 250 master's students as of last year, and 365 undergraduate students. So we are the second largest engineering department at CMU. So some key strengths of our undergraduate curriculum. We have a very diverse student body. So the 365 students include students from sophomore to senior. They don't declare until their sophomore year. 39% are female, 28% are underrepresented minorities. And we have a very strong community with a number of student organizations from ASME, which is the American Society of Mechanical Engineering, Pi Tau Sigma is the Honor Society, Women in Mechie, CMU Racing, Rocket Commander, a number of student organizations that I'll mention a couple of them later in their achievements. So our program, of course, addresses many of the standard mechanical engineering directions with some emphasis on AI and machine learning. But there's also a great deal of flexibility. 27% of our students pursue a double major, 17% pursue a minor, and 15% of the units come from elective courses. So if you look at the double majors, about half of them are double majors in biomedical engineering, as I'm sure Keith is aware of, and about a quarter are in robotics, which is in the College of Computer Science, and almost maybe a fifth are in engineering and public policy, which is a unique department here at CMU. There's a couple other scattered major or minors that we see there. Double majors that we see there, and there's any number of minors, 31 programs that the students have chosen recently, shown here on the right-hand side. So they have a great deal of flexibility to craft a degree that meets their interests and their objectives. So the students have a lot of experiences outside of the classroom in our department that help them build leadership, teamwork, project management, and technical problem-solving skills. In terms of clubs, a couple big ones, the Carnegie Mellon Racing Club has had a couple of recent first places in the electrical vehicle competitions. And CMU Rocket Command did really well in 2018 at the NASA student launch, and they won the Altitude Award, which requires them to drive the rocket to a very specific height, not higher or lower. In terms of undergraduate research, over the duration of their 3 years after they declare, something like 50% of our students participate in undergraduate research. In terms of employment, about 50% of our undergraduate students go on to get a master's or a PhD. About 40% are employed and 9% were seeking employment at the time I downloaded this information. The average salary is $85,000, pretty broadly distributed. And top employers include places like Boeing, Milwaukee Tools, that you may associate with mechanical engineering, General Motors, also some companies like SpaceX, which of course is in aerospace, Tesla, and then some tech companies like Microsoft, Facebook. So a real broad range of companies hiring our students, and these are only sort of reflecting the biggest ones. Our students in 2020 and 2021 really stayed in the Pittsburgh area. Perhaps this is due to the COVID situation, with some taking positions along the Northeast corridor, others in San Francisco and LA, and I guess Detroit is represented there as well. Okay, in terms of graduate curriculum, the domestic and international breakdown of the grad students is important. About 2/3 of our master's students are international. And something that's interesting, especially for the employers, is that we have significant number of master's students graduating in May, which you may expect, but also graduating in December, because several of our degrees are 3 semesters. We have 216 PhD students, about equally split international and domestic. So research is a key piece of the degree for many of the master's students, and of course for the PhD students. And the exceptional research areas in our department are metals additive manufacturing, electrical vehicles, that's from policy all the way down to the science of batteries, soft and bio-inspired robotics that really meshes in nicely with the robotics work done in the CS department or in the College of Computer Science. Air, climate, and energy spans a lot of research. AI and machine learning is a research area that we have several faculty members concentrating in, but it's also permeating almost everybody's research as a way to amplify our specific areas. So, for example, I work in heat transfer and thermal management, and some of the students that I work with are taking courses in AI and machine learning to make our work better, faster, easier. And of course, we have 3 or 4 faculty that work in biomedical engineering, and they complement the work done that's in the biomedical engineering department. Our students have a really balanced exposure to engineering and computer science. So if you look at the courses taken by our master's students, about 2/3 are in mechanical engineering. And this other chunk is really computer science, robotics, machine learning. There's a bunch of other courses taken in the College of Engineering. This could be just other departments in the college. And then TechSpark is our makerspace and machine shop, where the students get this hands-on experience, ability to build things for project courses. For PhD students, it's a little over half of the coursework is in mechanical engineering. A larger chunk ends up being in computer science and robotics. We have a number of project-based courses. These project-based courses give the students this really hands-on experience that we think is important to prepare them for employment. In this case, this is the Advanced Control Systems Integration course, and this quadcopter, they modeled it, and then with a quadcopter, they actually performed this experiment to try to get this ball in a cup. And we see that they're able to do this successfully, both in the video and in the simulation. And there's different projects each year, but this is a good example. We also have courses at the intersection of engineering and data science, teaching students how to work sort of in material science, for example, and identify the crystal structures that may lead to properties of materials that are interest, in this case, a high temperature ferroelectric material. The course is in Bayesian machine learning, and this is one example of a project in the course. Finally, many of the courses incorporate elements of professional development, whether these are project management courses or how to create a startup or leadership and communication. This is something that we find really important. And then the project-based courses, which may not sound like they're specific to professional development, all incorporate elements of public speaking, creating written documents professionally. So this is something that we take very seriously, and we want all the students to have this experience when they leave. There's a number of companies that work with our courses, whether they're supporting projects in some of the project courses, or they're funding our research. And I'll just flash these up here. Finally, in terms of employment status, this is a combination of MS and PhD students, but something like 84% are employed, about 7% go on to continuing education, which is probably master's students moving into the PhD programs, and then 7% seeking at the time that we looked at this, with an average of something like 95,000, pretty broad distribution. And if you broke out PhD and masters, you would see a distinction there. So here are the top employers. CMU is the top employer only because many of our master's students become our PhD students and our PhDs become postdocs. So if you take that away, Amazon becomes one of our largest employers, MathWorks, Apple. So not necessarily companies that you would come to associate with mechanical engineering, but we prepare the students to find these jobs. And finally, it looks like the master's and PhD students spread themselves out a little bit more to the Northeast corridor, to San Francisco heavily, some in Seattle as well. So again, thank you for your participation. I know that Peter and Keith are going to talk, but I'd be happy to answer your questions at the end.
Excellent. Thank you so much. Yes, as you do have questions, please go ahead and put them in the chat. I'll be moderating that towards the end. And Keith, we are going to move right along to biomedical engineering.
Right. So I just want to say thank you to everyone for taking the time to come today. Of course, now it's not showing up. Let me try again. Here it is. Okay. So I'm Keith Cook. I'm the department head of biomedical engineering. Things I'm going to talk about today are first the degree programs that we offer here in biomedical engineering, some of our areas of research strength, and then ways that we are really looking to engage with industry. So just briefly, I mean, we offer the full component of degrees. We offer a Bachelor of Science in Biomedical Engineering. We offer various types of master's degrees, and we have a PhD program. And I'll give you some more detail on these. One thing that separates out our biomedical engineering program is that every single one of our biomedical engineering undergraduate majors is double majoring. And you know, John showed on that slide that half of their double majors in mechanical engineering approximately were double majoring in biomedical engineering, and it's because of this policy. One of the things that we strongly believe at CMU Biomedical Engineering is that we want to turn out qualified, well-trained engineers from our program. It's very common that a lot of biomedical engineering programs are very general and lack significant depth in engineering. So the way that we create that engineering depth is we require everyone to be a double major, and so they're double majoring in biomedical engineering plus something else, such as mechanical engineering, electrical, chemical engineering, material science, and engineering. And then every single student is going to have a BME concentration that is related to their other major to ensure that our degree provides added depth in that area. And so these are the concentrations: biomaterials and tissue engineering, biomechanics, biomedical devices, biomedical signal and image processing, cellular and molecular biotechnology, and neuroengineering. We offer a variety of different Master of Science degrees. What I'm calling our sort of more traditional Master of Science degrees. We have two flavors. One is an applied study degree that is largely course-based, but they have one project that they must complete that requires them to do real-world biomedical engineering. And so that project could be done with industry, that project could be done in a research lab, and it could be done in the clinic at a hospital doing clinical research. And like John mentioned, those students are 3-semester students, so the program is about 16 months, including the summer. We also have students who are in the research option, and that's actually the majority of our master's students. That program is 21 months. They take less courses, and they have a very, very in-depth research project. So they're typically about 50-50 in classes and research for the first 9 months, and fully devoted to research for the last 12 months. We have a computational biomedical engineering degree. I think, John, you set me up nicely here on some of these points. John mentioned that machine learning sort of is in everything that we do. And so for that reason, we've created this computational biomedical engineering degree that focuses on both AI machine learning, as well as, I would say, more traditional differential equations type modeling. And so we have the 2 flavors, the applied study and the research option there as well. We have a new degree that's coming online, which is an AI engineering degree in biomedical engineering. That degree gets its soft launch this coming fall, with an official launch the year after that. So that program really focuses on AI with a 5-course sequence. So more AI, less biomedical engineering domain knowledge, but a healthy amount, both. And then we participate in the engineering technology innovation management degree, which I will let Peter. Peter, are you talking about that?
No, I'm actually talking about
you're
degree.
triple I, yeah, just triple
Yeah.
I. Okay, so there it's a mix of engineering as well as innovation management. So more business related, industry related coursework. Our research strengths in the department are neural engineering. We have a strong component of faculty in this area with strong research labs, strong in computational biomedical engineering. And again, I think you're going to kind of hear about that from really probably every academic department at CMU. And then we have strong labs in biomedical imaging as well. We're very strong in tissue and organ engineering, and that is both tissue-based organ development, such as biofabrication and bioprinting, as well as artificial organ design development. We're very strong in biomaterials and nanotechnology, medical devices and robotics, and then cardiovascular and pulmonary engineering. And again, the cardiovascular and pulmonary is both tissue related as well as device related. These strengths show up in some of the research initiatives that are at CMU, and I'm just going to name a couple of them. So we participate quite a bit in the Neuroscience Institute and the Center for Neural Basis of Cognition. Both of these have a very strong neural engineering component. We have the Bioengineered Organs Initiative that focuses on biofabricated, biohybrid, and artificial organ development. And then the latest sort of offshoot of that research area is that Carnegie Mellon University and the Mayo Clinic is now collaborating on the Transforming Transplant Initiative that develops really a wide swath of technologies to improve the practice of transplantation. everything from biofabricated organs to applying machine learning to improve transplantation. So I'm just going to close with means of engaging with our undergraduate students. Obviously, we appreciate when you hire our students as summer interns. I would also ask that industry groups think about sponsoring projects within our biomedical engineering capstone design course. That's a 2-course sequence. It's very unique because all of our students are double majors, and so you get teams that have chemical engineering, material science and engineering, electrical engineering, mechanical engineering on these multidisciplinary teams. Those teams are typically about 5 people working for 9 months at about 12 hours a week per student. For master's students, for our applied study MS students, again, we appreciate it when you hire our students as interns. They also have practicum projects. So those are 14 weeks long, about 12 hours per week. We are opening up our research master students to industry sponsorship. And so if you're interested in sponsoring a student for a research master's program project, please get in touch. Those projects are very in-depth. So the students work 9 months at about 20 hours per week, an additional 12 months at about 40 hours per week, just dedicated to that research project. In our new course that is part of our computational BME and AI engineering degrees, we have a course called AI Applications in Biomedical Engineering. That's team-based. So much like our senior capstone design course, you'll get a team of people working for 14 weeks at about 12 hours per week on a specific project. So we'll also be taking project ideas for that. I know we're going to wait till the end for questions. So I look forward to your questions, and I've provided my email address if you'd like to get in touch with me. Thank you.
Excellent. Thank you so much, Keith. All right, Peter, why don't you go ahead and close us out?
All right. Well, thank you, everyone, for joining us. So I'm going to talk about the Integrated Innovation Institute. So we span 3 disciplines. So our education, we're focused on products and services. We're focused on training students who are going to be practicing professionals. And if they're going to create products and services, well, one thing they do need to get their engineering right, because products have some function. They work, they accomplish things. So engineers, they make things happen. So we span a lot of disciplines in the sense that we're looking at more generalist functionality rather than training students in a specific area like chemical engineering. We also teach business classes and design, as in industrial design, communication design, UI, UX design. So that interface with people. Successful products, not only do they need to function in the world of engineering, but it's people who interact with them and purchase them. So that would be the world of design. And then whenever you're creating value in the marketplace, you want to stay afloat, you want to keep going. So call that economic viability, which we'll label business. The word integration is important to us. Collaboration is already good across these disciplines. And so somebody who more is on a business side needs to understand the engineering and understand their language. But with collaboration, it's still an us and their language, us and them. We get our students working so closely where after a while they drop their background, and it's us, it's we. They're aligned in their objectives. It's really product success, service success is that they're going to. We have 2 degrees. These are both graduate degrees, master's programs. One of these is here in Pittsburgh, and this is a Master of Integrated Innovation for Products and Services, which we'll shorten to MIPS going forward. A cute little acronym there. It's training people to innovate products and services. We also have a degree at our Silicon Valley campus, and think of this as products in the software arena. The title name there is software management, and they're focused on the business of software. So Turning to the first of these degrees, it's really looking at the creation of products and services in general. We have two versions of this degree, kind of like my colleagues had different degrees. We have some who take 2 semesters and they graduate in May, so 9 months. The other is 3 semesters and graduate in December. Total, we have about 50 students coming in a year, and about 2/3 of these stay on and graduate in December. So that gives you rough approximation of how many students you could hire in May versus December. As far as kind of where do these students head, they come from either a business or design or engineering background. They're cross-trained across these disciplines in our program, and they end up in a variety of locations. And what are they looking for? So somebody with an engineering background, they're not changing careers. They're wanting to be not only an engineer, but also they're wanting to do additional types of thinking tasks. Same with a business student. A business student doesn't want to just be an MBA and be siloed in business. They really are wedded to product creation. That's their love. And so again, they're cross-trained. So where do they end up? Well, you see the variety of titles that are here. Development engineer, R&D engineer, marketing specialist. I know this is an engineering section, but my students, some of them are in engineering and some of them are elsewhere. The other degree, our Silicon Valley degree, is really focused on innovation products, but in a software kinds of product. Here they have graduation in August and also in December. Again, we have about 50 students coming in each year. These job titles you can see from our Silicon Valley degree are software engineer, manager, product manager, project manager, these kinds of titles. Most of these jobs have tended to be on the West Coast, as you can see here as well. In addition to full-time jobs, we have interns we really appreciate. As Keith said, we appreciate when you hire our students, whether full-time or as interns. And so do keep that in mind, that we're always looking for really good collaborators for internships. This would be in the summer. And then in addition to hiring our grads, you have other employees, all of you who are from HR. And keep in mind that you can send your other employees to Carnegie Mellon without having them relocate. And so our program has an online set of certificates that also stack into a degree. These are real school. We are proud at Carnegie Mellon of rigor and training. So these aren't these 2-week certificates. These are 14-week certificates where they're getting course credit. And if they take enough of them, they get a degree. So keep that in mind for upskilling or ongoing training for your other employees in your organizations. We also have capstones that we run. And here's some past capstone sponsors. We tend to work with larger businesses and applied projects on innovation projects of interest to them. And that's my presentation. So we can turn to Q&A across the group.
Excellent. Thank you so much, Peter. All right, so if everyone can go ahead and put questions in the chat, I will be reading some of those out. If you prefer to unmute your microphone and ask, that's fine too. We'll go ahead and start with one that we have in the chat here. So this is from someone with the National Reconnaissance Office. Are your students interested in roles with federal agencies, particularly intelligence agencies?
I think our students would be interested in those positions. I'm not sure if they were necessarily reflected in some of the most common employers, but that may be because they don't report them. But certainly, I think some of our students are well prepared with problem-solving skills that would benefit these jobs.
I'll echo that. Our students land in a diverse array of industries, so I would imagine that this could fit the interests of some of our students. We, like many of the programs, we have a number of international students, and so do keep that in mind.
Yeah, I'll comment on that. So I think my honest comment is I'm not about intelligence agencies. I'm not really sure. We haven't been approached, and so but I do know that several of our graduates do go work in federal jobs. I think for biomedical engineering, it's probably more common to have our students go work for the FDA. That happens quite a bit, but we've had students go work for other federal agencies. To Peter's comments, our students are majority domestic.
Thank you. And I also just put a link in the chat for those of you who are not familiar with Handshake. Handshake is the recruitment platform that Carnegie Mellon uses. And so we do encourage employers to post positions in there. And when positions are posted, students can find them. We can also advertise them and push them to specific departments. So if you are interested in BME students or you are interested in mechanical engineering students, we can push those Handshake postings directly to specific departments. And so I put a link in there. If employers would please grab that, that would be very helpful to you.
Yeah, I would just say mechanical engineering has a new professional development course for the master's students. And with a couple of the lectures in that course, we would like to bring employers in to give presentations. So if that's something that as an employer would interest you, I think you have about 100 captive master's students, and we'd be happy to invite other departments to the sessions. So let us know. You can directly email me. I wrote my email earlier.
Great, thank you, John. Anyone else, please put questions in the chat, or you are free to unmute your microphone and ask as well. I can go ahead and add one. What is the most popular skill that your students learn that may not be directly taught in your classes or in your program?
I guess I would just say perseverance. We challenge our students, and I think that they become adept at juggling multiple challenges at the same time and sticking with it. I guess I'll leave it at that.
I'd say communications as well is something that students often get at probably all of our programs, is that they need to learn about selling what they're doing in addition to doing it, or showcasing why they're working on it.
Yeah, and I guess I can just add that I think some of our courses require teamwork and project management, and I think that the students that excel in those courses really become good at working with their team, designating roles, and doing things on a pace rather than at the last minute.
Great, thank you. I know some of our faculty today mentioned sponsored projects and capstone projects. If we have employers in the room today who are interested in partnering, what is the best method for connecting with you? Should they contact you directly? Is there someone else in the department that you would prefer to have them contact?
You're all welcome to contact me directly, and I can steer you to appropriate staff members, and depending on your questions, your interests.
Great, thank you, Peter.
Same here. Yeah, I think the emails would go to different people if it was for graduate courses or undergraduate courses, but I'm an easy starting point.
Yeah, I agree.
Excellent, thank you.
And if you mention that you were at this session in your title, I'll definitely read the email.
All right, any final questions? Any employers have anything else they want to post in the chat?
This was very helpful. It also gives us a contact so that we can share, the internships and our entry-level positions for your candidates, because we are chomping at the bit to have them, especially in the intelligence communities. So I will be sure to reach out.
Great.
Wonderful, thank you. All right, if there are no other questions, then that will conclude our session for today. So thank you very much, everyone, for joining us. I'm going to go ahead and pause our recording.